प्रिय विद्यार्थियों, पिछले व्याख्यान पर अपन ने गैस्ट्रुलेशन का परिचय, उसकी परिभाषा, उसकी विशेषताएं व उसके 5 चित्रों के माध्यम से हमने समझने का प्रयास किया था। आज का व्याख्यान अपना गैस्ट्रुलेशन की एक एनिमेशन फिल्म है, छोटी सी फिल्म है, 3D फिल्म है। 3 डायमेंशनल होने के कारण से अपने को समझने में आसानी होगी। निश्चित रूप से ये फिल्म की भाषा जो इसमें प्रयोग की गई वो अंग्रेजी है। मैं मानता हूँ और विश्वास है कि इतनी अंग्रेजी हमें आती है, फिर भी अपने को कोई शब्द या कोई वाक्य नहीं समझ में आए, आप मेरे व्हाट्सएप पर या व्यक्तिगत फ़ोन करके आपकी जिज्ञासा शांत कर सकते हैं। लीजिए, अब इस फिल्म का आनंद लीजिए और पिछले व्याख्यान को स्मरण रखिए और उससे इसको कोरिलेट करिए।
Day 13, the blastocyst is firmly implanted in the endometrium. We'll now make sagittal cuts through each constituent part, one after another. The outermost is the syncytio trophoblast, which secretes the beta-HCG we detect in pregnancy testing. Next is the cytotrophoblast, followed by extraembryonic mesoderm, inside of which is a space known as the chorionic cavity. Sitting in this cavity and also surrounded by extraembryonic mesoderm is the developing embryo, the parts of which we'll discuss next. The epiblast sits atop the hypoblast, and together these are known as the bilaminar disc. Cells of the hypoblast extend out to form this space called the yolk sac. By this stage, the epiblast has developed inside it the amniotic cavity. We'll remove the outer elements in order to take a closer look at the bilaminar disc. At the cranial end of the hypoblast lies the procaudal plate, an area in which columnar cells are present. It serves as a marker of the embryo's cranial aspect. The end point of gastrulation is the formation of a trilaminar disc made up of ectoderm, mesoderm, and endoderm. The cells that make up these layers were all once of the epiblast. This transition is achieved as follows. Cells of the epiblast migrate inward, downward, and then differentiate. From either side, this continuous passage begins like symmetrical waterfalls. To be clear, it is the moving cells which produce this form, as shown here. Macroscopically, this makes a visible groove in the surface of the epiblast known as the primitive streak. Its presence marks the beginning of gastrulation. At the cranial end of the streak, cells are migrating thickly, forming this circular depression known as the primitive node. As the embryo grows, more cells migrate and the primitive streak elongates. Cells which differentiate into endoderm displace cells of the hypoblast and eventually replace it entirely. Cells which remain in the upper layer differentiate into ectoderm. And cells which differentiate into mesoderm force their way between these 2 layers. Around day 16, cells migrating through the area known as the primitive node begin to form a hollow rod which curves toward the cranial end of the embryo. It extends toward the procaudal plate and is known as the notocaudal process. We take a coronal cut now. We see the hollow rod, and if we move through it now, we should also see its connection to the primitive node. As the notocaudal process grows longer, the embryo continues to grow in all dimensions. Around day 18, the notocaudal process fuses with the endoderm. From this to this. It's now known as the notocaudal plate. Being continuous with the primitive node, this now allows free passage between the amniotic cavity and the yolk sac. Let's take a look through to solidify that, starting at the primitive node. We're looking down through what is known as the neuroenteric canal, and the space we can see into is the yolk sac. It's theorized that this brief communication between amniotic cavity and yolk sac allows pressure equilibration between the two cavities of the early embryo. Once that has been achieved, the two edges of the notocaudal plate come toward each other and eventually fuse. They become a solid rod, the notochord. Noto is Greek for back, and the notochord acts as the structural backbone of the developing embryo. By this stage, intraembryonic mesoderm fills almost all the space between the ecto and endoderm. Apart from the space the notochord occupies, it is absent also at the oropharyngeal membrane, located where the procaudal plate once was, and the cloacal membrane. These are structural elements of the embryo that currently exist as ecto and endoderm tightly adhered. And that concludes the process of gastrulation, from bilaminar to trilaminar.